We are talking about arcs, chords, and tangents, and we want to use properties of tangents. So earlier, for number 5, it said solve for x. In h, I, and j, assume segments that appear to be tangent are tangent. So that's h, I, and j. For G, it says, is the line segment HI a tangent? And basically all we have to do, if it were a tangent, we would know that this has to be a 90-degree angle here. So that makes that a right triangle. So what we'd want to check is Pythagorean theorem true? So we would make this A, and we could say a squared plus b squared equals c squared. So a squared plus b squared, and we'll have b would be 40 equals c squared. And we're not saying that it is equal, but we want to check if it's equal. So I'm just going to put a box right there. In this case, a is 9, so that's going to be 9 squared plus b, which is 40 squared. We still have the box right here. And c squared is 41. So we plug those in our calculator and we get 81 plus 1600. And we're still checking to see. And 41 squared is 1681. So when we add these two together, we get 1681 is equal to 1681. So HI, line segment HI, is tangent. So that was what we were checking for. So then we can say line segment HI is tangent. Because Pythagorean theorem was proven true. Now for the other two examples, we want to assume that segments that look tangent are tangent. And so for H, we want to draw those tangent lines and show that on here. So I'm going to draw a line from the center to where P would be. And that is a 90-degree angle there. And then we also want to draw a line showing that it is perpendicular, therefore tangent there. If it is tangent, which it shows there, then we know that these parts are congruent. So we can say PW, line segment PW, a little more room. We can say line segment PW is congruent to line segment QW. If two lines are tangent to a circle and meet at the same point, then that means that they have to be congruent. And then we can substitute in 3x minus 6. So that's going to be equal to x. And then the first thing we want to do is we want to subtract x from both sides. And on the right side, we're going to be left with 10. And on the left side, we're going to be left with 2x minus 6. And then we can add 6 to both sides. And we're left with 2x is equal to 16. And then when we divide both sides by 2, we get x is equal to 8. We have 2 more examples, and again, we also want to assume that that lines that look tangent are indeed tangent. Okay. And we want to find x. So if that is tangent, then what that tells us is this is a 90 degree right here. So if that's 90 degrees, we should be able to use Pythagorean theorem and solve to find out what the missing value is. All we have to do is identify what A, B, and C are. So in this case, our radius is going to be our A value, our x is going to be our B value, and 17 is going to be our C value. So we can substitute those values in. Pythagorean theorem, we have, maybe there'll be a little more room if we move it over here. Pythagorean theorem, we have a squared plus b squared is equal to c squared. We can substitute our values in. A is 8 squared plus b, in this case we don't know what it is, so it's going to be x squared, and c is equal to 17 squared. So then we have to use our calculator. 8 squared is 64 plus x squared. We're going to leave it as x squared because that's what we're trying to find. And 17 squared is 289. So we can subtract 64 to get x squared by itself. And we get x squared is equal to 225. And then we can take the square root of both sides. And then we get x is equal to 15. We have one last example, and that's going to be very similar. I and j are going to be very similar to each other. Assume segments that look tangent are. So we have tangent there, Pythagorean theorem. The one addition that we have to do is we have to find out what our radius is. In this case, our radius is 21. So that means that this y to a here is also going to be 21. So it's going to change our values a little bit. So in this case, our c value is going to be 21 plus 8, which is going to be 29. That's going to be our c value. Our a value is 21, and our b value again is x. So we can substitute those values in. A squared is going to be 21 squared plus b squared, which is going to be x squared, is equal to 29 squared. Again, we can use our calculator. We can use our calculator, and 21 squared, once we have in our calculator, is going to be 441 plus x squared is equal to 29 squared, which is 841. So we can subtract 441 from both sides of the equal sign, and we're left with x squared is equal to 400. And then we can take the square root of both sides. And then we get x is equal to 20.